Right, welcome everybody, and thank you for attending my event. It means quite a lot to me. This is something that I'm very passionate about, and it's great to see a bunch of people who are actually willing to listen to me talk on it. I did want to put an upfront warning before I start. This is a very dense topic, and some of the slides have quite a lot on them. So please bear with me. I'm hoping that it's all good information, that you can cleave something good from them anyway. And also, when I say practical domain-driven design, this is going to be how my product engineering team, the project area engineering team at Click Travel, that I've worked at for so long, that's why I say I'm not head of it or anything, but it feels like a good family of people, have used DDD, that's domain-driven design, practically to improve our technology and our processes and our software. So I'm very happy to answer any questions. I've put you all on mute to begin with, but I will unmute you at the end. Hopefully I'll have enough time to answer any of the questions if they do come up. So why talk about domain-driven design? In truth, it's had a massive impact on me as a software engineer over the last few years that I've been using it. And due to these experiences, I really wanted to share them with other people and kind of pass on what I have learned over these years. I hope I can illustrate why I think it's been so influential throughout this presentation, and that you might learn a few things about DDD along the way. So before I do that, I'll admit 2 more people, and then we will begin with the actual slides. So this is really a journey that the department has been on for around 5 years, maybe about 6. It's got a bit cloudy. It's been a long time, and one that I thankfully have had a chance to be a part of. During this time, it's changed so many aspects of the development process. And this talk is about what and how we use DDD to do this. So I look forward to some explanations on how it's impacted the choices we have made on things like architecture, way of working, and even some code examples of how DDD can actually be implemented in software. But all journeys need a beginning. So how did this one start? Well, it all started with the decision to retire the old service and infrastructure. It had become a giant monolith with so much code. It was increasingly harder to spot where the model started, the view came in, and the controller did all its processing. This made it very difficult to test using modern methods, and the development cycles really started to get drawn out. It had become that anti-pattern of a big ball of mud, which I've put a picture of in the slide. That is a big ball of mud. And the software wasn't bad, but it was just increasingly harder to work on. It was time to ring in the new. So with a fresh start, there were so many questions. Our ways of working were being replaced with new ones, and the DevOps movement was really gaining some traction in the community. It would be wrong to say that we weren't worried about what the impact was going to be of changing all the things at the same time. We were talking about new build tools, new deployment pipelines, new cloud technologies, and most of all, new code. How could we convert all that old code into a bigger, better service without breaking what we already had? And what we already had was a winning award still. We knew that we had to make sure that we truly understood the real core of what the software we had already developed. In steps DDD. One of my colleagues had heard of a technique that might help us achieve this task and began reading what we all started calling the Big Red Book, and that's pictured there on that slide. Soon he had convinced the right people, and a small team of us were all reading this Big Red Book. It was written by the author Vaughn Vernon, and is packed full of how to practically use DDD to solve business requirements. I would highly recommend it. I've read it from cover to cover, and it's packed full of some really, really good stuff. So we really wanted to get grips on how we could apply these teachings within this book to the issues of mass change that were coming up. So soon it was clear that DDD could offer an answer to helping us migrate to a new technology stack, while maintaining the flavor of our old software, which people were still liking. We got in contact with Vaughn Vernon, and he actually graciously came and taught us and took us on a crash course of his practical DDD techniques. This really kicked the DDD journey off with a bang, And before we knew it, I was working in a new team that was using DDD to help us move forward with our new platform. So that was me setting the scene. I really wanted to put it out there why we started using DDD and how we got involved in this crazy DDD world. So now I want to do a little bit of a skim over some of the main concepts of DDD. This whole topic is very large, and throughout this talk I will only be touching on a handful of the things that we have used because it's just so dense. But these are the things that I really feel had the most impact on the engineering department and in turn the entire company of Click Travel. The main thinking of the practical side of DDD is actually split into two sections. You have strategic patterns, and these set about trying to define your domain and thinking on the larger picture so you can better reason about that design. And you have tactical patterns. These are more code focused and are about putting designs into sensible structures within the software so that they can be expanded and maintained over time. Once again, I've massively oversimplified these two areas. So if this is really sounding interesting to you, please dig a little deeper, read the Red Book or read bits of the Red Book. It's really, really good stuff. But I thought I'd go into a few examples and maybe that might help me explain a little bit further on both of these strategic and tactical points. So the first strategic point, domains. At the very heart of DDD is this idea that there is a domain that you are trying to write software for. For example, our domain is business travel here at Click Travel. And within that one domain, there might be many smaller subdomains that might be of focus to the business and our users. These can be different types. You can have core ones. These are the ones you really want to take time to understand and polish the quality of. An example for us is booking. We're a business travel company. We do booking. Booking is something that's very core to us. You have supporting ones. These have to be in place in order to make the other offerings, the core offerings, kind of work, but they're less important to the end user. So billing is one of those for us. Very important to us as a company to get paid, but the end user doesn't really see the billing on many of the screens, so it has less impact to them. And there are generic ones, which you've kind of decided you need, but your business might not be focusing on those main areas, and maybe a third party could fill that area a little bit better. An example of this for us is expenses. There's lots of companies out there that do web expenses and it works perfectly with travel. We could fill that area with a third party and code around another piece of technology, but it could be a domain that we see we want to fulfill, but just possibly not with bespoke software ourselves. So that was domains. So on to another strategic one, bounded context. And this is the idea of deciding what software should sit in each of your subdomains. Within each of these subdomains, there will be services that sit as solutions to the main domain problems. These are named bounded contexts or also BCs. I'll probably use BCs quite a lot throughout this presentation because that's another way of expressing the long word bounded context. And there may be many of these BCs within a single subdomain if that subdomain is complex enough. Each BC is likely to be a single deployable project that encapsulates a portion of the subdomain code. Right, I'm just going to check to see if there is anybody waiting to come in. Do apologize, I thought this might be a good place to break. No, brilliant. Let's continue onwards to another strategic one. So this is a ubiquitous language, something that at Click Travel, you'll have heard this many, many times. We really like the ubiquitous language. And we also shorten that down to UL, as ubiquitous language is quite heavy to say all the time. And it's a real favorite of mine, as I think any project, not even a DDD one, would prosper from the ubiquitous language. The idea of the ubiquitous language is defining terms within your domain that have real meaning. Then they can be used in all conversations during design of features and also within the code itself. You're supposed to name domain objects after these terms from the ubiquitous language, so they actually end up within your code in your domain layer. I wanted to put a couple of examples out there of ubiquitous language terms from our own ubiquitous language in our users subdomain. So we have in our user subdomain a ubiquitous language term called personal profile. And a personal profile is a user who is a principal of the platform and can log in or authenticate with the platform. But we also have something that's quite similar, but subtly different, called a team profile. And those profiles link directly to a team, which is kind of like a customer in our platform who cannot log in, but can be booked for. And before we had these terms to distinguish between the two, sometimes conversations were a little bit harder to keep on top of. People didn't know whether they were talking about one or the other, but now we know personal profile means this, team profile means this, and we have plenty of these terms across all of our domains in our platform. So now onto the tactical side of things. So this is more the code side of things. And a really broad example of a tactical pattern is the domain layer. And this is part of the software that is made up of objects and services within your software. I've put another warning in here. Please bear with me. I've got to say a lot of things about this because it's such a core part of it. So just stay with me. So domain objects aim to encapsulate real domain concepts inside a programmatic object. And although heavily influenced by object-oriented programming, the idea that there is a single place to hold and manage properties and processes of key actors within your domain has led to really high-quality software, even within some of our more functional code bases. So these are code bases that don't actually practice object orientation at all. In DDD, you reason about different types of domain objects at the design stage. For example, you might have a user domain object, and that might need to change its properties quite frequently and be uniquely referenceable by other things. These are characteristics of entities within DDD, which are generally persisted as complex objects by your services. On the flip side, you might want to store a more simple value like a name for that user. Names rarely change, and two of the same names should probably be classed as equal. This could be designed as a value object. Now you might be asking, why make the distinction between these two different things? Well, it kind of helps with things such as testing. Entities are harder to test than value objects, and the size of the data that you're actually trying to persist. There's this idea of aggregates in DDD, which I'm not going to touch on because it's very complicated, but they can be made up of entities and value objects, and depending on which is which, they're stored in different ways. It kind of just makes everything a little bit easier in this domain layer. Domain events, sorry. So event-driven systems have all kinds of positives, bringing in things like decoupling and the ability to easily action things in the background away from your end users. DDD offers a tactical pattern in its domain events, and these are just messages that are published from domain objects that represent actions that have occurred within the domain. An example might be one in response to a name change of that user that I mentioned in the previous slide. Now, any other bounded context can subscribe to that event and take an action when that user's name changes. Domain events should represent a state change or a significant process occurrence within the domain and should not be commands. This is seen as an anti-pattern. If you make them commands, then you are telling what the action should be upon receipt, and that doesn't make things as flexible as if you're just saying something has changed. So this really helps with decoupling and with the synchronization of different services when you've got many of them like we do. Coming to the end now, bear with me, this is the last tactical pattern. So another concept that shouldn't be considered just for DDD projects, I think, because I think it's just a real good practice, is making sure you put your software in logical places. At the center of a DDD project is this idea of a domain layer that only cares about domain things. Not how to persist data, not where the data came from, certainly not concepts outside of its domain. The domain layer should read similar to a sentence from the Ubiquitous language. You should be able to look at our code bases, and if you know the Ubiquitous language, whoever you are, you might be able to look down it linearly and kind of see what is happening within the domain. All other technology concerns should be abstracted away from this layer and into other layers of the software. And I wanted to put a little shout out to command and query separation here as well. It's not strictly a DDD concept, but it's definitely something that the Red Book talks about heavily and that we have implemented and found to be very, very beneficial. So command query separation is great. So into my next section, that was a very, very speedy overview of the main concepts of DDD. And I am really simplifying all of this to make it easier to digest in this presentation. Please read up on the Red Book on any of these ideas if they pique your interest. I'm probably not doing it the justice it deserves, but we'll continue onwards. So moving on in our department, now that we understood these tactical and strategic patterns, we realized that they could certainly enable something that we were really eager to get on board with, a microservice architecture. And for those who are not familiar with this is having many smaller software services make up your overall back-end offering, a modern and now highly adopted technique for developing and deploying software. So DDD was going to enable this for us, or we hoped it has done. So we started to introduce DDD into our development processes. We adopted domain sessions, which brought all the interested parties together at the start of a story. And we would run through the current operations of what they look like, maybe in code, maybe in real life, and start to really build up that ubiquitous language based on the terms that we heard people saying from these domain experts. We really saw an upturn in attendance from stakeholders and domain experts who were all wanting to have an input into the resulting technology. This led to requirements being more fleshed out and testers being able to turn those requirements into suites of BDD tests and specifications of example that we as the engineers could code up and have executing automatically whenever the code base changed. We also made the decision to embrace the hexagonal architecture for all of our new microservices. Now you might be thinking, hang on, James, this doesn't seem to be much about DDD. This is a totally unrelated architecture that you can use for anything. But in fact, DDD had a huge impact on making this decision for the department. This will become a little bit clearer on the next slide. I'm actually going to have a picture of what the architecture looks like, so hopefully that'll help you digest kind of what it is. But it's really mostly about how DDD stresses the splitting of concerns and responsibilities into layers within an architecture. It allows you to extract away technology from the domain and leave it very pure, and have a clear layout for your code with adapters to the domain, such as email clients and database clients that adapt to the layers below it and all the way down into the domain. So let's have a picture. And here is a very simplified version of the hexagonal architecture, but I think it kind of speaks enough here. So a super quick breakdown of the architecture, or at least the one we used when using DDD, is there is this outer layer, which we call the adapter layer, which manages all incoming and outgoing communication and adapts that stuff to the layers beneath it. In red, you can see the application layer, and that has cross-cutting concerns such as access management to the domain features, which keeps things like that and security out of the domain, which is things that the DDD book stresses it should. And the domain is what we used to call in our team the GUI center of our services, and it should model the processes within the subdomain. This is where the domain layer that I mentioned in an older slide comes in and sits within all our microservices, free from any technical concerns that are actually handled at higher levels of the architecture. So I'll leave that up for a second, but we have used this in all of our services, no matter what generation they were, and it's only done as well. We used the strategic patterns to start scoping out our domain and splitting it into those core, supporting, and generic domains that I mentioned earlier. Within those, we began designing bounded contexts that would fill those solution spaces. The image on this slide shows a picture of something similar to what we had drawn on the wall once in a meeting room in our old team many, many moons ago. It essentially shows our domain, a click travel, and then the contextual mappings we expected our platform to actually have. And this isn't the real picture, but if it was the real picture, you would see something that's quite different to what the platform looks like now. But there was some similarities. So there was definitely some benefit of us doing this at the start and trying to map out where we thought our domain was, our subdomains were, and where all the software would sit in order to have a platform like the one we have today at Click Travel. So That was the beginning. Now I'm fast forwarding about a year, maybe 2 years into the future of this journey, where DDD had been wholeheartedly adopted by every team in the department, and the development of the legacy system had all but stopped, and the new platform era was totally upon us. We had a handful of core domains and some bounded context implemented in each of those core domains, and this had given us a little bit of time to analyze what was working and what we needed to work on in order to get true benefit. I have named these the champions and the challenges of our first generation of software, and I'd love to walk you through a few of these. Some of these are a little bit more technical, and if you actually came here to see some code, you might actually see some code on one of these slides, or maybe a couple of these slides, who knows. So our first champion, ubiquitous language. You're going to be fed up of me saying that by the end of it. But these are the reasons why I believed it was a champion of this process and a champion that we still use today. We've been using it for years. It's been so useful because of the focus it has on making everybody understand the same terms. They're used everywhere. They're used in code. They're used in test specifications, in story docs, in demos. Even when we're handling support cases here at engineering, we try and talk in those words with our online services team, because we want to drill in the fact that this is a term, this is what it means, and it just makes things easier to converse about, and everything is consistent. We have even found that over the time it has evolved and increased, and the language has become bigger and broader as the subdomains and the bounded context within them grew in complexity over time. So we have plenty of these documents all knocking around. On to the next one, and here's the code, the mystical code. So our next champion is the domain object. Having well-named objects due to the ubiquitous language, and you having a single place to look for logic, has many examples. This is the first code example. I hope everyone can see it. There's a fair bit, not really, but it's a super simple example of that user class in Java that I made reference to earlier. It has a constructor, which has various different domain constraint validations at the top. So the values are passed in from anywhere, it doesn't matter, but then it makes sure that those values are consistent for the domain rules by asserting various things on them. Then it sets them in the way that it wants. Maybe it might need to format it, maybe it doesn't. And then an object of that type is constructed and handed back to a layer before. These classes and objects also maintain their own mutations. So there's an update email address there that also has a little bit of validation in it in order to make sure that the email address is conforming to the formats that this current domain actually wants it to be, and then it will set it. So with these kinds of patterns, engineers can be assured that when they use these objects, the domain constraints have already been put in place, and they don't need to consider that complexity in the new code that they're using. They just need to use these objects. Also, I wanted to say that because of the fact that it's so pure in the domain, testing these objects is actually a hell of a lot easier. There's no real dependence that's needed in here, so you don't have to mock out lots and lots of things. And for any of the people at Click Travel that are listening now, all the mocking that you can do in testing sometimes becomes a real nightmare. So not having that mocking just makes testing so much easier. So domain objects, big winner from us. Another champion, my final champion, I think, is domain events. DDD did not come up with the idea of the event-driven paradigm. I'm not going to say that it did, it's just borrowed it. But by making events bubble out of the domain each time a significant event occurs, such as creating a new booking or deleting a user, we have seen so many advantages. When domains have been extended and more bounded contexts have been added or developed, we've found that events that are already being published have allowed services to instantly hook into these major domain of actions. Things such as business metrics and critical alarms, things that we're putting more of in now, we're stressing these DevOps things even more now. These can be easily driven from events without actually having any performance or adverse performance on the end user. So our domains and services don't even need to have direct access to each other, which is something that DDD stresses. They should not have direct access to them. They are islands, and they should only speak to each other through other mechanisms. And domain events is a perfect mechanism because it's just send out, fan out, and whoever wants to listen to it listens to it and takes an action on it. So that's how the state of our platform is conveyed between our many different bounded contexts and across different domains. Now onto the challenges, the things that stunk a little, the things we needed to kind of tweak and kind of make our own. So this first one I've called the design session sync, and we've got a lot better at it, to be fair, over the years. But for anybody who was in the original team when we first started doing this, this was a real problem. So although design sessions worked really, really well, sometimes they took up a lot of time. You had multiple stakeholders, product owners, testers, domain experts, a handful of engineers, and a large portion of the time, the conversation spiraled out of control and lots of people's time was wasted, and there was no real useful outcome that came out of these sessions. So in order for us to combat this, we realized there needed to be a few things that needed to change. First of all, a sufficient amount of research needed to happen before these design sessions. And also, if you gave someone the task of being the stream leader, which is a term that we use here at Click in order to kind of lead a piece of work or a story, they could be in charge of maintaining the order of these design sessions so that they didn't get as derailed as they could be. And also reduce the amount of people that were in there. 6 seemed to be a good amount. Sometimes we had 10, 11, 12, and it just wasn't working for us. So these rules, we abided to them, and these sessions have become a lot more valuable over the years. And it doesn't mean that other people can't get involved. We just produce something at the end, and then we share it with the wider team afterwards, and they can critique it at their own time, more of an asynchronous way. I think this is my last one in this section, and this is domain silos. And rich domains are amazing, and they've definitely led to higher quality software in Click Travel. But rich, in my head now, can also be considered a synonym for complex. And complexity comes with a real high cognitive load. We're still struggling with this problem here at Click. And this is where a single team, or maybe team members, have worked on a domain for a very long time. And those people are the only people who really, truly understand the bounded context and the softwares that sit in that domain. This is not because the code is a mess. It's more that the story after story have been implemented within this domain, and the domain rules have become so complicated, they're really hard to pull apart. So when team members leave, join, or move, their silos of knowledge move with them. So we're currently trying to tackle this by spreading domain features across multiple teams and not having teams in charge of just a single domain. All engineers should get familiar with the domains and make these silos so much shallower. So fingers crossed, we'll be nailing this soon, hopefully. So that was my champions and challenges. And they were from the first few years of using DDD. This next section is more about present day techniques and the kind of things that we've had to tackle as our current technology stack has changed, or the landscape of technology has changed, such as AWS. These are techniques that you can't read about in the big red book because they're kind of our bespoke methods in order for us to continue to use our beloved DDD practices in less object-oriented ways. As we've gone further, we've kind of become less object-oriented. Probably the whole engineering community probably has gone that way, but that's what we had to kind of tackle with. So, boom, in comes Lambda. AWS Lambda. It came into our department like a wrecking ball and smashed everything we currently knew. If you're unaware of what AWS Lambda is, in short, it's a deployment tool that allows you to harness the true nature of cloud computing. You can execute small, fast-running functions at a massive scale in what is now called serverless. Lambda functions get invoked by something, execute your code, and tear down. No server sitting there constantly waiting for requests. And you know what? We really liked that way of thinking. So we jumped in two-footed very early on and decided to throw away Java and start using JavaScript as our new language to execute within that environment. I didn't know whether to put Miley Cyrus on there, but I thought that was probably a funnier GIF. Right, JavaScript is very different to Java. Once it had been successful in a few new bounded contexts using this kind of new Lambda technology, we made use of it in all of our projects. This meant that we had to start upskilling in JavaScript, and in particular Node.js, which is quite different to Java. Even though the name kind of suggests that it isn't, it really is. And even though JavaScript did support classes, we deemed it not best practice because the community was kind of saying that it wasn't best practice at the time. So we decided against their use. So now we had to find a way to keep our domain objects without actually having strongly typed classes to manage the creation of those objects. Validation libraries. This is how we found we could still have our domain objects without actually having classes to control them. So we started thinking about what the real value we were gaining from domain objects. And we decided that making sure the domain constraints are abided to would allow objects to have the right data and keep their consistency. So validation libraries such as Joy were looked at in order to maintain the shape of these domain objects. The example code that I have on the slide is what new constructors kind of look like in our Node.js projects. Much like the Java constructors, all the parts that make up the domain object are passed in, then fed into a definition of sorts that contains the domain rules, which is then validated. If it passes, the object with that structure is returned, and that will be used in other domain actions or passed to higher layers of the software. If not, an error is thrown, which can be handled in the other layers, just like it was in Java. So just quickly walking through that code, I've got it on a big screen in front of me, so bear with me for looking up there. You can see the definition is created and there are keys that are passed in there, and you can use various different requirements to say this is a required thing, or this is an optional thing, this is a string, this is a number, and there's a regex thing there to make sure that a string has a certain look and feel about it, and then it's validated using that function there, validate, and if it's good, that object comes back in the shape that you expect it, and that is returned. So this is how we're doing new domain objects in a Node.js non-object oriented world. Transactions were different. We had to find new ways to save objects to the database, as our old ways relied on Java annotations and really aspect oriented programming. Also, we had inline event publishing that kind of put things on a transaction list to be actioned by a separate thread, and Node is a single threaded thing. You can do clever things with it, but we wanted something that was a little bit more simple, certainly in the early days. So all of that was quite difficult to emulate in Node, so we had to think out the box on how we could do this. This led to code, a little bit like the example on this slide, where you have to load up a kind of transaction object that you can pass around to the various different layers. It holds the events and the objects that might need to be persisted, and you can kind of pass it around. And then when it gets to the right layer in the software, you can say, right, now do this transaction, and it goes away and does actions on various different things. This allowed us to keep the domain code clear of adapters, and have the upper layers in that hexagonal architecture do the things that it's always been doing in the Java code and in the Node code. So that was great. Transactions changed. And promise chains, if anyone has used Node, then they might know that promise chains are a nightmare, and they can be a real nightmare, certainly if they get out of hand. So in keeping with the sentiment that each layer has its own logical concerns, promise chains made this much more difficult, mostly because of their syntax and because of their asynchronous nature, which was different to what we were dealing with in Java. We had to make sure that each layer returned a promise that resolved to the object that was applicable for that particular layer. So things in the domain resolve to domain things, application to application code, and in the adapter layer, things like REST responses, it would finally resolve to a REST response. It also made things much more difficult to read than what was in Java. Java at the time was a hell of a lot easier to read, until async await came along. We now use that syntax absolutely everywhere. And if you are using Node, and you can use it, but you're not, my professional advice is do use it. It has made our lives so much easier. and it really is, it makes no programming become a joyful thing again, thankfully. So another change happened. We decided on a new functional code style, which changed things again and the way that we deal things. So at the start, we didn't adopt a functional programming style, but then an ex-colleague convinced us all of the benefits. Things like testing, testing became easier because there was no side effects and there was no direct mutations to data. But of course, this brought in even more challenges to DDD because it was a totally different way of thinking about how to program things, especially when DDD is so rooted in that object-oriented paradigm. So now, none of our domain objects actually ever directly mutate. We wanted to make sure that domain objects never got directly mutated. That's the functional direction that we decided to go in. That was a big change to the way that we currently use DOs. And of course, things do need to change. That hadn't changed. Our domain still needed objects that needed to have updates, that needed to have various different changes. So how do we go about doing this? When things now need to change, objects have to be passed back as deep copies of themselves with updated values overwriting the old ones for those properties. So I've got a code example on the slide. So the domain object that wants to be changed has to be passed in now because that's the way that it works. It needs to work with its values that are in there. It could be destructured. That object is not destructured. That's a whole object, but we do use destructuring heavily as well in our code. And then we do the same kind of domain validation that you probably saw earlier in the Java side of updating the email address. This one's a little bit more simpler, but we could have the same kind of thing to make sure that the email address itself is a good email address. And then we use the spread operator heavily. And the spread operator is those 3 dots that you see before that user variable. And what that does is just copies everything from that object, all of its properties, it spreads them out and it kind of puts them so that they can be applied to another object. And so that copies all of its properties to a fresh JavaScript object, which you can see by those curly braces before the return, and replaces that current email address with the one that's passed in. Then it is returned. So almost that is the same operation that we did in Java, but just a completely different way of thinking about it because of this new functional style. And the functional style also allowed us to start thinking in discrete domain functions, which in turn allowed us to place domain functions in a per JavaScript file. So this is a single function in one file, or at least one single exported function in one file. So you've only got access to one thing. This new best practice, it was a new best practice that we saw coming out of the Node.js community, and we kind of liked it. We thought it was a nice way to go. It was working hand in hand with our new functional style, but we still wanted to logically group things in a sensible DDD way. So the way we decided upon is like the example code structure you see on the slides. Each domain object or service is now a directory which holds a single script and it has functions that are all the domain actions that it can do within it. So there you can see there is a group, and that group has a create group option. Before that would have been a method on a Java object, but now it's a single file function in a directory, which is easy to read. That's why we have them like that. So it hasn't changed very much, but allows us to conform to this one file per function type style. So this is quite a change from the old Java class system, which sometimes had hundreds, and depending on what domain we're talking about, possibly thousands of lines of code, rightly or wrongly, depending on the maturity and the complexity of the object in question. So now we don't have that at all. Actually, a large portion of our functions in the domain are tens of lines long because they're just one file that's exported, which is much, much easier to test, read, all those kind of things. So we are coming nearing the end. So I'm kind of wrapping up and saying kind of the conclusion and why we have continued to use DDD. So as you can see, we've had to adapt our ways of coding and designing and just our general way of engineering around DDD when things didn't quite fit because technology has changed, the world kind of changed. So why did we continue to use these set of techniques that were designed for technologies we were not really making use of? Well, I hope the next few slides kind of answer that question. I'm also aware that I put quite a few words in that slide there, so I hope that you've had time to read it while I've been rambling on. So these are just my viewpoints and the reasons why I think DDD has worked for us so well. So I truly think that the two parts of DDD complement each other extremely well. Eric Evans, I think, was the guy who came up with DDD, and I think when he thought about it, it was a really, really good idea. Deeper thinking about your business and what the value is and what you want to deliver eventually results in all parties understanding the software better. Be that the engineering process that goes into it, the delivering of the software, the maintenance or the continued expansion of those features and that software. We have seen microservices that have been iterated on 10 times, probably some even more than that, 20 times, all with the same level of design and consistency within its domain, even when technology has changed vastly around it. We have also coded against third parties that fill our generic domains when we just didn't need a bespoke answer of our own. So we've taken on board the concept of bringing in something, buying in something instead of making it, which overall has made things cheaper and probably higher quality for our end users. So these are the two sides of the coin. I feel like the strategy side of the patterns has really helped to bring the business closer. Be that through making an effort to all try and speak in the same ubiquitous language to reduce confusion and increase the service area of business requirements, or letting domain experts and stakeholders define what are our core domains so that we can get more focus on it from the engineering department. It all helps us to engage better and deliver technology that our end users really want to use. And tactics. On the other side, there's the tactical patterns, which we as engineers, I as an engineer, have really prospered from. And some of the things that we've really prospered from over the years have been self-documenting code in the domain layer. You can literally look down our code, and if it's written correctly, it speaks for itself. If you know the domain, if you know the processes, you can look in that area of the code base and just read down it, and it kind of is like a script that you kind of can see what's happening in each place. And it's traced like real world processes. We've also broken bits off larger microservices and re-engineered them from Java to JavaScript. And when we did that, most of the time, we only had to consider the domain layer because that was the bit of real importance. All the other bits in the other layers were kind of more like boilerplate. So we didn't have to, we knew that if we took that domain section and copied that across, we were getting all the goodness from that domain. And finally, as technology has advanced, certainly AWS, which is something we at Click use like for everything, it's our bread and butter, things such as Lambda, API gateway, step functions, and DynamoDB improvements, we've never really struggled to integrate with these into our microservices, whether it be old code or these new code with Node, with all our new kind of practices. And I believe that that's because DDD allows the domain to sit so far away from technology that we can swap things in and out, and it doesn't actually affect the core meaning of our services. We just swap out these adapters from this hexagonal architecture. So it all kind of works together. And that, people, brings me to the end of my domain-driven design talk. I hope you all enjoyed it. I did want to do a few shout outs to a few people that have kind of helped and been really impactful along the way. Vaughn Vernon, special thanks to him. He came and he taught us, and ever since that I've been hooked on DDD. It's just been a fantastic journey that I think even if I don't use DDD in other projects in the future, some bits of it will still follow me. Stefan Westcott, he was the original guy that decided to say, should we use DDD? And that started the kind of journey off. So cheers, Stefan. Much love. Golnaz and Bash, they're mentors of mine who've done so much for me, and I've been on this DDD journey with them from the start. So thank you very much. Chris Hearns made his way onto this as a late arrival because he looked through these slides and essentially did a spell check for me. Anybody that knows me knows my spelling is appalling, so thank you for that. And if there are any spelling mistakes in these slides, I do apologise. And I also wanted to shout out to unsplash.com because I nicked a load of stuff from their artists and I didn't have enough space to put all of them down, but they're really good art on there, so thanks to you guys. And of course, thanks to Brum Tech Week for allowing me to do this event and the sponsors that are sponsoring Brum Tech Week that allowed this kind of happen and allowed me to do a talk on something that I'm very passionate about. So I hope that you all enjoyed my talk. Thank you for listening. And I suppose I'll open the floor to any questions that anybody has. Someone that I've just admitted. So I will now allow you to unmute yourselves. Please don't all talk at once. I suppose, do you want to, anybody that wants a question? Oh, we've already got hand raising, so that's what we'll go for. We'll go for hand raising. So the first hand that I've seen is from Dan. You can unmute yourself now, Dan, if you want, I think.
Cool, yeah. Yeah, I had a quick question about, so we were doing, I'm from Click as well, so if I say we, this is why. We were doing a DDD design long ago. And when we moved to a serverless architecture, why didn't we just adopt a Java standard Lambda sort of as the best practice? We could have just brought over all the same sort of DDD class objects, that sort of stuff.
It's a very good question. And the real reason was, I believe we were so early adopting Lambda, the Java side of it was very poorly supported. And the community was saying, don't use the Java bit. Now, I think it's now quite good. And I even think that I read an article a couple of probably years ago now that said that they've got the Java executing extremely fast in Lambda. And it's like a really good to use. But to begin with, it didn't have as much love. It was like Node was the first one they plucked up and kind of put in the environment. And because we wanted it now, that's very much what Click Travel's like. And it's a good thing because it means that we're on the edge of technology all the time. We just decided to go with Node. So does that answer your question, Dan?
Yeah, that's very clear. Thank you.
Fantastic. Right, has anybody else got any questions? If you just raise your hand, I think, or you can just unmute yourself, I suppose, because I didn't have to unmute Dan anyway. Let me just see. Dan actually came to the front, so if I get the participants up. Let's move on to another screen of mine.
Okay, go on then, James. I have a...
Oh, Vincent.
So you've described how there are kind of various sweeping technological changes that kind of help drive this process forward and rediscovering new ways of doing things, but kind of still progressing the DDD paradigm. Do we have any tricky question? Do we have any feel for upcoming sweeping changes in technology? Are there other things in the air, or are we in a period of kind of maturing the current tools that we're using?
It's a very good question, and also a very hard question to answer. My thumb is not on the pulse with AWS as much as some of our other colleagues here at Click Travel. I do read a few things. I personally would say my gut feeling is the fact that we've adopted this functional way of working, and Node.js is still the flavor of the moment, I think. I mean, I think the developer of Node.js have actually brought out a new language because he felt that Node.js had gone down a different route. But anything that's been so heavily adopted, like Node.js, will take a long time to not be the kind of favorite kid in the group. So I think while we're sitting with serverless technologies, which is quite modern, and Node.js and functional programming, I think that we might be okay for a while. But you'll know as soon as me, Vincent, when things change, we'll be on it. Does that answer your question, or have I just rabbited to try and hide the fact that I haven't got an answer?
No, that's good.
Great. Right, I'll leave the floor open to questions for just a couple more minutes, but I don't want to take up anybody's time longer than is needed. So does anybody else have anything to ask? I feel like I should have a countdown type audio going on. If it was a meeting that I was running, I would say that is a long enough pause for us to say goodbye to each other. So thank you so much again for joining and listening, and I really hope that you've got some good things out of there. So thank you very much, guys.